All right, class, welcome back. This is 7.6, solving radical equations. I'm gonna start off with how we would solve just irregular equations if we wanted to isolate x. So if I want to isolate x, what I'm gonna do is I'm gonna undo any addition or subtraction connected to it. So for instance, this positive 7 is connected to this x through addition, or it's worth 7. So I'm gonna do the opposite. Whatever I do to one side of the equation, I have to do to the other. And so I would get that the solution is x equals 5. On this other one here, I would say, oh, hey, this is a negative 2. So if I add 2 to both sides, then I would get that x is a negative 1. This is isolating the variable, but now we're going to isolate a radical. So what do these equations look like? Well, let's start with the square root of 3x minus 2, and that's going to be equal to 4. So if I want to solve this radical equation, I've written the steps out over here. I want to isolate one radical. Well, this radical is already isolated. There's nothing connected on the outside of it to by addition or subtraction, so it's completely isolated. So now what I want to do is I want to raise both sides by the power of the index. Well, in this case, remember, if there's not an index, then the index is 2. So I am going to raise this side to the power of 2 and this side to the power of 2. We're also going to be using the rule that any radical times itself is just going to be the thing inside. That goes for radicals like this too. If I had the square root of 3x minus 2, and I multiply that by the square root of 3x minus 2, all I have left is this radicand. Okay, so I'll get the radicand, and then 4 squared is going to be 16, and now this looks just like a regular equation that we would continue to solve. We get that 3x is equal to 18, divide both sides by 3, and x is going to be equal to 6. Now, this only had one radical in it, so I isolated it. It was already isolated. We raised both sides to the power of the index, and I didn't need to repeat steps 1 and 2, and we solved the resulting equations. But we still have to do this last step, and that is to check all of the solutions, because sometimes you can get a solution that does not work. Okay, so here, order of operations says I do this multiplication first, so I get the square root of 18 minus 2, which is the square root of 16, and the square root of 16 is 4. So this is a true statement that 4 does equal 4. So that's our first problem. Our second problem here, we'll have a little more, tiny bit more work to do, but let's do the square root of 16x minus 3 minus a 4x, and that's going to be equal to 0. Again, my goal here is not to isolate x out the gate. If I have a radical term, my goal is to isolate the radical term. So I need to pick one to isolate. Well, this 4x is related through addition and subtraction, so I'm going to add 4x to both sides. Once I've done that, then I can now raise this to the power of 2. Again, the index is 2 because it's a square root. So I have to do the same thing to both sides. All that will be left in here is just this radicand, this 16x minus 3. And here, remember that this means 4x times 4x, which is a 16x squared. Okay, and now I don't have another radical, so I'm going to skip step 3, but I need to solve this resulting equation. But this resulting equation, I need to know, how do I know which way or what I'm doing with this? Well, because this equation has a squared term, then I want to isolate or get everything on one side equal to 0, because I'm going to have to factor here. Again, that's because this is a squared term. So I'm going to subtract the 16x and add the 3 on both sides. So I'll get that 0 is equal to the 16x squared minus 16x plus 3. Now I need to factor You thought factoring was done, but it's not. It's going to be haunt you forever for the rest of your math career. I need to factor this 3-term polynomial. The first thing I'm going to do is look for a GCF. So there's not an x or a variable term GCF, but there is not also a constant GCF. So I'm going to count the number of terms. I've got 1, 2, 3 terms, and the way we're going to factor this 3-term polynomial is through synthetic factoring. I'm going to take 16, which is a, and multiply it by 3, which is going to give me a positive 48. I'm looking for factors of 48, of a positive 48, that are going to sum to a negative 16. You can just start listing factors, like, 2 and 24, and 3 and 16, and 4 and 12. And we can stop here because if I had both a negative 4 and a negative 12, I could get those to sum to a negative 16. But they also multiply to a positive 48. So here's our check on that. So those are the factors we want. I'm going to write each factor over a. And then I'm going to reduce those fractions. So the negative 4/16 is going to reduce to a negative 1/4. And the negative 12/16 is going to reduce to a negative 3/4. Okay, so from here, we make these into factors. So I would have a 4x minus 1 and a 4x minus 3. But this is all still equal to 0. Kind of running out of room here. Now what I want to do is I want to set each factor equal to 0. So if I set 4x minus 1 equal to 0, and I solved for it, I'd get that 4x is equal to 1. So x is going to be equal to 1/4. So I want you to notice here that it's 1/4. And if I solve this one for 0, I'm going to get 3/4. So what happens when you're using synthetic factoring, this synthetic factoring is a shortcut, you're going to get these as your solutions with opposite signs. It's just the way it works out. You can see the work here. This factor, when it's set equal to 0, I get 1/4. It's the opposite sign that I have here. So my two solutions I'm going to get here are 1/4 and 3/4. So this is what should work when I plug them in back into this original equation. So we still need to do that. And to do that, I'm going to erase this work for the factoring here and plug it back in and see if it works. So I've got the square root of 16 times 1/4 minus 3 minus 4x is equal to 0. Sorry, I forgot the x here. So 16 divided by 4 is going to give me the square root of 4x minus 3, and that is going to be equal to, minus 4x, and that's going to be equal to 0. I didn't forget the x, we plugged in 1/4 for it. Wow, sorry. And we should be plugging in a 1/4 right here as well. Oof, guys, stay with me here for just a second. Sorry, I'm substituting this value for x in this equation. So let me start this part again. I've got the square root of 16 where I see x, I'm going to put the value 1/4. All right, so should be good there. 16 divided by 4 is 4 minus 3. This is going to be the square root of 1. And here, 4 times 1 is 4, divided by 4 is 1. And the square root of 1 is 1. And 1 minus 1 is indeed 0. So this is true. Sorry for that for 1 second. Okay, so we also need to check 3/4 this same way. Scratch that minute there where I had a brain cramp. And we'll do this again. So let's check the 3/4 and see if it works. I've got the square root of 16. I'm going to plug in 3/4 for x in both of my x's and see if this is a true statement. That's going to give me 48 divided by 4, which is going to give me 12. 12 minus 3 is the square root of 9, which is 3. And here, 4 times 3, or these 4's will cancel, so I'll just have a 3 minus 3 equals 0, and that is again, a true statement. So both of these solutions work. Occasionally here you can get, the reason why you have to check the solutions, this isn't just like, hey, did I do it right? But you can get an extraneous solution here. So we have to make sure that we plug in all of our answers to ensure that they work. All right, so next I want to do another one. This next one, let's try a cubed root of x plus 1 plus 5 is equal to 3. So again, cube root of x plus 1 plus a 5 is equal to 3. Well, I want to isolate this radical. Okay, I've noticed there's a radical here, so I'm going to subtract the 5. So I get that the cubed root of x plus 1 is equal to -2. Now I want to raise both sides by the index power. Again, the index power is 3 in this case because this is a cubed root. So I'm going to raise this to the third power, and I'm going to raise this to the third power. Both sides of the equation. When I do that, any, whatever this n is, if I'm going to raise it to that power, it will undo, sorry, the rule here, if I raise it to the same power, it will undo. So I'll just have what's inside of here. The rule that I had written over here, not quite the same rule. So again, if you raise it to the same power that the index is, then you only get the radicand left. -2 cubed is going to give me -8. There's no more radical, so I'm going to go to step 4 and solve this resulting equation. And I get that x is equal to -9. Sweet. That wasn't too hard, so let's check that solution and see if it works. So I'm going to plug in where I see x at -9 plus 1 plus 5 is going to be equal to 3. Well, -9 plus 1 is the cubed root of -8. The cubed root of -8 is a -2. 2 plus 5 is indeed 3. So this is a true statement. Okay, so that is with a cubed root. I want to do a couple more here so that we can kind of look at the gamut of everything that we might be able to see in our homework and the types of problems that we might get. So we're going to work the square root of 9 plus x, and that is going to be equal to an x plus 3. So again, my goal here, as soon as I see that there's a radical in an equation, okay, and I've got an equation, I'm going to immediately be like, okay, got to isolate this radical. Well, this radical is already isolated. There's nothing connected to it through addition or subtraction. So then I'm going to go and raise both sides by the power of the index. So I'm going to square this side and I'm going to square this side. So here I'm just going to get the radicand. But right here, a lot of people will make the mistake and they'll say, oh, x squared plus 9. The problem with that is this does not equal that. When I have a squared term here, this means that I have x plus 3 times x plus 3. And when I FOIL this, I'm going to get x squared plus a 3x plus another 3x for a total of a 6x plus a 9. So again, if I just kind of dumped this in here, I'd get this x squared and the 9, but I would miss this middle term. So you got to remember that this means that you expand this and FOIL. So now that I'm looking at this, again, I've got to solve the resulting equation, but I determine how to solve it. In this case, this is not linear, again, because this is squared. So I'm going to move both of these to this side so that I can get it equal to 0. I'm going to subtract x and subtract 9 from both sides, and I get that 0 is equal to x squared plus a 5x. Okay, so from here, again, I'm going to factor. First thing I'm always going to do when I factor is look for a GCF. Here there is one. The GCF is x, and all I have left is x plus 5. So I'm going to set each factor equal to 0. So I'm going to set x equal to 0 and x plus 5 equal to 0. Well, what you'd have to substitute for x here to make it 0, or this is literally the statement that says x is 0. So I've got that x is 0. Here I'm going to subtract the 5, and I get that x is -5. So my two solutions here I get are 0 and -5. But again, we have to check those in the original equation to make sure that they are correct. And here I'm going to take the square root of 9. I'm going to check the 0 right now first. That's going to be equal to 0 plus 3. So I have the square root of 9, which is 3, and 0 plus 3 is 3. So this is a true statement. Okay, so we know that 0 works. And now I'm going to do this again, but with -5. Again, this checking is not just for fun, but it's a necessary part of the problem to make sure that you aren't getting the wrong answer. Okay, so 9 minus 5, this is the square root of 4, but a -5 plus 3 is a -2. When I take the square root of 4, I get 2, and 2 does not equal -2. So what happened here? Well, this solution here does not work. We can see that this is a false statement. So this is an extraneous solution that in the process, when I squared this, because there's a variable under this radical, remember that we have to keep whatever's under this radical positive because it's squared, but when we introduce the squared here, this was mathematically something that we came to get as an answer, but actually does not work. So again, this is why we have to check all of our solutions. So we're going to take x equals -5 off of our list and say, just have x equals 0 here.